Okay, so we're looking at the average value theorem and what it finds for us. So the average value theorem is going to tell us the average y value over some closed interval. It states that if we can find the integral over the closed interval from a to b, then the average value of the function is going to be equal to this. It's 1 over b minus a times the integral from a to b of the function. It's not difficult. All it's saying is you find the integral, and then you have to put 1 over b minus a out in front. That's all it is. So find the average value of f of x equals 3x squared minus 2x on the interval from 1 to 4. That's part A. So I want you to understand what we're actually doing. Here's our function, 3x squared minus 2x. Look at the function. So it's saying from x equals 1 to x equals 4, which is pretty far up there. Let me make the scope a little higher. So from x equals 1 to x equals 4, we're supposed to find the average of all those y values. Look at this table for a minute. Let me get it back to the standard. When I look at when x equals 1, the answer is 1. When I look at when x equals 4, the answer is 40. A lot of people think, well, if I want to find the average value, I would just add 1 and 40 and divide by 2. That doesn't find the average y value because there are infinitely many points. To find the average y value, you would theoretically have to add up every single y value there is and then divide by the number of values there are. That's impossible to do. So that's why we have to have this method here. So this would be A, this would be B, this is our function. And now we just plug in. Average value equals 1 over b minus a times the integral from a to b of the function dx. That's my setup to find the average value. So I'm going to have 1/3. I add 1 and I divide. What's that going to give us? What's the integral there? X cubed, good. This one, I add 1 and I divide. What's that going to give us? X squared. Okay, so now I'm going to do 1/3 of whatever I get when I plug in 4 and plug in 1. Okay, so when I plug in 4, 4 cubed is 64 minus 4 squared is 16. Minus, plug in 1. 1 cubed is 1 minus 1 squared is 1. So 64 minus 16 is 48. So I'm going to have 1/3 of 48 minus 1 is 0. So what's 1/3 of 48? 16. Okay? So 16 is the average y value over the interval from 1 to 4. Now, in part B, it's asking us, find the values of x in the interval for which the function is equal to its average value. Well, here's my function, and I want to know where does my function equal my average value. So I have to solve this. So I'm going to have 3x squared minus 2x minus 16. Factor that, 3x and x. Can you think of how it would factor? What are numbers that multiply to be 16 and subtract to be 2? Well, actually, just multiply to be 16 for now. 8 and 2. So I'm going to try putting the 8 here and the 2 here. That's not going to work. But if I put the 8 here and the 2 here, see how I get a 6x and an 8x? So that would work on the factoring. All right, so then I'm going to get x equals 8/3 and negative 2. But read the directions. Find all values of x in the interval for which the function equals its average value. In the interval, our interval goes from 1 to 4. Which of those numbers is in between 1 and 4? 8/3. So this is going to be our answer for part B. Most things that can be done algebraically can also be done graphically. Let me show you how I could have done this. I already have my function in here. Now I want to know, where does my function equal 16? Well, here it equals 16, but what do you think that point is? -2. I want to find that point. Second trace, calculate, point of intersection, get close to it, enter, 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 and there it is. 2.6 repeating. Is that 8/3? Yeah. 8/3 is 2 2/3, isn't it? So it's the same. All right, so we can do it either way there. Let's do the next one. Find the average value of y equals 2 sine x on the interval from 0 to pi. All right, so then in part A, to find our average value, it's 1 over, here's my a, here's my b minus a is just pi, times the integral, here's my a, here's my b, of 2 sine x dx. What's the integral of sine x? Negative cosine x. So I'm going to get 1 over pi times -2 cosine x from pi to 0. So I'm going to have 1 over pi, -2 cosine of pi, minus -2 cosine of 0. The cosine of pi, think of your unit circle. Here's pi. That point's -1, 0. What is the cosine of pi then? Nope, cosine's the x value. What is it? -1. So I'm going to have 1 over pi times -2 times -1 is +2 minus what is the cosine of 0? Right, here's cosine. It's just going to be 1, isn't it? So 2 times 1 is going to be 2, so it's minus -2. So I have 1 over pi times 2 plus 2, so that's 4 over pi. So 4 over pi then is going to be the average value, the average y value. So in part B now, it says, find all values of x in the interval for which the function equals its average value. Here's my original function, 2 sine x. When does that equal 4 over pi? Well, I can't factor that. There's no way to factor it. The only way I can solve this is to just use my graphing calculator. That's my only option. So I would now have to put in 2 sine x. And I would have to put in 4 over pi, zoom trig, because we're doing trig. We do zoom standard if it's just a regular function. Okay, I only want to find the answers between 0 and pi. Okay, so now I'm going to change my window. I only want to see x's between 0 and pi. That'll make it easier to see how many answers I have. So this is my curve just between 0 and pi. There's my average value. So how many answers am I going to have? 2. So to find them, second, trace, calculate, which do I want? Intersect. Enter, oops, get close to it. Enter, enter, enter. And so one of my answers is 0.69 radians. My other answer, I got to be kind of close to it. I'm going to jump down to my other curve to get there quicker. Enter, enter, enter. And this one is 2.45 radians. So both of those x's are going to be the ones that are equal to the average value. See how it kind of makes sense? Like that point right there, that's the average height of all those heights that we have. Okay. All right, last problem here. Given the function shown, evaluate the integral from 1 to 6 of the function. That's the first part. You have to think outside of the normal way of thinking on this. We're trying to find the integral from 1 to 6 of this. We're given a picture. We're given a diagram. Does anybody have any ideas of what we could do? Megan? Exactly. Yes, make rectangles and triangles. Think about what this means. See, we're so used to, anytime we integrate, we add 1 and we divide, we do all that. We're used to doing it algebraically. But on this one, I don't really know the equation of this, the equation of that, the equation of this, the equation of that. I mean, I could figure it out, but it's way too time-consuming. Integration means the area from the first x to the second x, bounded by the curve, here's my curve, bounded by those x's and bounded by the x-axis. So if it means the area, can't we just find the area? Watch what I'm going to do. I'm just going to create some spaces here. Here's one area. I can find that pretty easily. What's the area there? Count the boxes. What is it? What's the area? 5. I'm done with this. Okay, so I've got that much of it. 5 plus. All right, let me find something else easy to find the area of. I can find the area of this triangle. Base times height divided by 2. What's the area of that? 1 times 2 divided by 2. What is it? 1. I'm done with that. Find another area. Okay, this would be a trapezoid, so I'm going to break it up like this and this. So what's the area of this? It's 1 times 1 divided by 2. What is it? A half. Finished with that one. What's the area of this one? 1. It's just a box. All right, let's go down to, let's go all the way over to here. What's the area of those? 3. Done with those. Lastly, this one. What's the area of that one? A half. So now add them up. 6, 7, 10 and a half and another half, 11. So 11 is going to be the answer to that integral because integration just finds the area. So we are finished with part A. Part B says find the average value on the interval from 1 to 6. So now out of all these y values, I've got to find the average one. This one really takes kind of a critical thinking skill to figure out what to do. How would I now find the average value? Look back at what the formula is for average value. Here's the formula for average value. Look at what we just found. Megan?
The 1 over 6 minus 1 times 1.
Yes. Blake, is that what you were going to say too? Yeah. Great. Good job, guys. So, they are correct. We would do 1 over 6 minus 1. We already know this answer. We already know the answer to this part of it. We just found it. It was 11. So it's going to be 11/5 would be the average y value. Good job. All right, so that's the only thing new that'll be on your quiz on Monday. You've got the review.